In this lab, we're going to consider friction. So this cart, although it's considered to be a low friction dynamics cart, there's still friction. You can't get rid of it totally. So what we're going to be doing in this lab is to measure the coefficient of friction between the cart and the track. Now, to do that, we need the angle of the incline, and we need the acceleration of the cart while it is coasting on the hill. Now, the cart is coasting on the hill on the way up and the way down. So we're actually going to measure both accelerations. So let's start out. We do not need the mass of the cart. And you should see that when you do the derivation in this lab, that the mass gets kicked out of town. So all that we need to do is measure the angle of the incline, and then the acceleration going up the hill and the acceleration as it coasts down the hill. We'll be measuring the acceleration with a motion detector. Okay, the motion detector sends out a sound wave which reflects off of the accelerating cart, and then that information is sent to the computer, where the information is interpreted as a velocity versus time graph. We will then take the slope of the velocity versus time graph to get the acceleration. Let's talk about the friction on the cart. When the cart is coasting up the hill, we have a component of the cart's weight directed down the hill. We also have a force of friction which is opposing the motion of the cart. So that would also be down the hill, right? Because the cart is moving this way. So there's a force of friction opposing that motion directed down the hill. So can you see that since there's two forces acting on the cart down the hill, its acceleration is going to be greater than it would be if there were no friction. So in other words, it's going to slow down at a quicker rate. It's going to slow down with a greater acceleration with friction than without friction. Now, when the cart is coasting down the hill, friction acts up the hill, right, opposing the direction of motion of the cart, but you still have the weight vector acting down the hill. So now you have these two forces opposing each other. So the acceleration of the cart down the hill will be less than it would be if there were no friction.